Welcome to Making and Treating of Steels course. Please note that it is updated Unit 1 syllabus. There are minor changes are added for this and make it as updated syllabus for Unit 1. And coming to the typical classification of steel is done based on composition. Based on the carbon range, plain carbon steels, it is further called as low carbon, medium carbon and high carbon steel and mild steel. Based on the alloying addition, low alloy addition, high alloy addition. Low means 5%, high is greater than 15%, medium is 5 to 10%. It is called alloy steels. Based on the addition of chromium and nickel, you can make steel to stainless. That is why it is called stainless steels. Based on the addition of tungsten alloying element percentage, it is called steel to tool steels, such as cutting tool steels. And coming to the production method, based on the LD converter and continuous casting process, it is varied. Mainly plain carbon steels are produced, and from the electric arc furnace you can produce alloy steels, special steels, stainless steels, many things. Even combination of LD converters, steel process and argon oxygen decarbonation process, vacuum oxygen degassing process, you can convert the steels to inclusion free steel, special steels, stainless steel, duplex steel and triplex steels. And coming to the finishing method used, it is called extrusion method, forging method, cold rolling and so on. And going to the form or shape of the product after finishing operations, such as wire, bar, rod and so on. These things are eligible for manufacturing industry. It can go for as a sheet to the car outer cover, and it can go as a train track rod from this particular structural materials. It can go to the automobile industry. And deoxidation process, aluminum strips are added to remove oxygen from steel making, and based on the removal of the oxygen percentage, it is called killed steel and semi-killed steel. If partially removed, it is called semi-killed steel. If completely or negligible amount of oxygen is removed, it is called killed steel. And coming to the microstructure, based on the parent microstructure austenite and ferrite, these steels are called austenitic steels and ferrite steels or stainless steels. Based on the process adapted, such as heat treatment process and continuous cooling transformation, time temperature transformation, the steels may vary to bayonetic steels, perletic steels and martensitic steels. These are the phase transformed from parent phase, such as austenite and ferritic. Bayonet and perlite martensite are phase transformed microstructure steels. And coming to the physical properties and mechanical properties and electrical thermal properties, the steels may vary based on the standards such as ASTM standard. Based on the heat treatment normalizing process to improve the ductility, hardening process to improve the hardness, annealing to improve the strength, temper to improve the precipitation hardening process. These processes are adapted to convert the steels into further eligible properties for the application. Grades based on the ASTM, ASI and EN England standard, American Iron and Steel Institute, American Society for Testing of Materials. These grades of steels may vary. And coming to the quality control specifications, such as ISO 2000, ISO 1900 and quality assurance QA category, quality controlled QC category, how this process is performed, what kind of inspection is adapted. This QA and QC is provided for the steels. Coming to the raw materials for steel making are source of metallic iron, example liquid pig iron, and oxidizing agents. Pure oxygen is purged in the case of LD converter process, and flux such as lime is added to remove the impurities in the form of slag, to convert the impurities in the form of slag and to allow it to the float on the top of LD converter or ladle while you are pouring the liquid steel. And source of heat, it could be the chemical source, it could be the thermal source. For example, in the case of LD converter, the liquid pig iron, the thermal heat develops, it is the source of heat in the case of LD converter. In the case of electric arc furnace, electrical energy is supplied from DC outside, it is the source of heat. And further, deoxidizers, so adding the aluminum, it maintain the temperatures during the tapping towards continuous casting process. Aluminum is forms as a aluminum oxygen. It floats on the top of liquid steel in ladle. It forms immediately in solid form. You can remove the oxygen. Further oxygens are removed in the hot metals such as liquid steel. Alloying additions based on the chromium, nickel, cobalt, it is called alloy steels. Based on the refractories, acidic, basic refractories are suitable. For example, LD converter, basic refractories are suitable. In the case of electric arc furnace, half of this lining is acidic, half of this lining is basic, so that you can produce the special steels and stainless steel. All those things are possible. Now let me go for detailed explanation one by one. Coming to the source of metallic iron, molten pig iron is also called as hot metal. If phosphorus range is varying less than 0.5%, is called Swedish iron. If it is greater than 1.5, it is called Thomas iron. Usually phosphorus supposed to be 0.2 to 0.4 once you produce from LD converter. These are the steel scrap, and sponge iron is another source of metallic iron for the electric arc furnace. And oxidizing agent, pure oxygen is used through lance. In the case of LD converter, lance is nothing but tube or nozzles. Coming to the fluxes, what is the main function of flux? To bring down the melting temperature of gangue or impurity materials, reduce the viscosity of the slag, and decrease the activity of some components such as activity of silicon, activity of manganese, so that in the form of impurities it will float on the top and it can be removed easily. And example flux materials, limestone, calcium, dolomite, and bauxite, fluorospar. These are the variety of materials are used or in practice in the present integrated steel plant as fluxes. Going to the source of heat, chemical source, it could be the solid by using pulverized fuel such as charcoal, and liquid such as oil, tar, petrol, and gases, producer gas forms in the case of sponge iron production process. And blast furnace gases is also as source of heat. It is being used in the case of steel production process. Electrical, it could be the induction principle heating or resistance heating such as muffle like ladle, and arc heating process. Going to the alloying additions, some of the deoxidizers to remove the oxygen, aluminum, silicon, to remove the oxygen, these things are used. To remove nitrogen, zirconium, boron, titanium are used. And some alloying additions, chromium, tungsten, and so on are used. Ferroalloys, if chromium and iron is more percentage, it is called ferrochrome steels or ferromanganese steels. Going to the why refractories are used, what is the main purpose of these things? It is basically to minimize the heat losses from reaction chamber, to allow the thermal energy based on the in and around during the process of steel production. These are the few examples of refractories and its melting point. Usually the melting point of refractories compared to the pure metal is very high. For example, aluminum melting point is 660, whereas Al2O3 melting point is 205. That's why these things are suitable for using refractories. The outer body of LD converter and electric arc furnace is made up of refractories. One need to notice these things.